Good afternoon, everyone. My name is Kanaha Divakar, Assistant Professor, Department of Pharmaceutical Analysis and Chemistry. I am currently working in Sri Shanmuga College of Pharmacy, Pullippai. So, my topic is UV visible spectroscopy. So, introduction of UV visible spectroscopy is spectroscopy is the branch of science that deals with the study of interaction of electromagnetic radiation with matter. The matter means the atoms are molecules. It absorb the electromagnetic radiation, is produce the energy, is converted to lambda max. Okay. Second one is so two types of spectroscopy here. First one is atomic spectroscopy and molecular spectroscopy. So atomic spectroscopy is this is the spectroscopy is concerned with interaction of electromagnetic radiation with atoms. So second one is molecular spectroscopy. This spectroscopy deals with interaction of electromagnetic radiation with molecules. Okay. And second slide is frequency. It is defined as number of time electrical field radiation passed within a second. So it is the unit of frequency is Hertz and wavelength. Wavelength is distance between the two nearest parts of wave. For example, distance between the two nearest dots. And what are the principles involved in the UV spectroscopy? It is the measurement and interpretation of electromagnetic radiation absorbed or emitted when the molecules or atoms, ions of sample move from one state to another state. Means normal small molecular atoms or ground state where applied electromagnetic radiation goes to ground state to excited state. We are stop going to electromagnetic radiation. We are stopping the electromagnetic radiation when the molecules or atoms go to the ground state. So it carries certain energy that is called lambda max. This lambda max is going to maximum wavelength. That is the equation is equal to hv. It's equal to energy in joules and h equal to Planck's constant and v equal to frequency in a second. So what are the UV spectroscopy? So is UV spectroscopy concerned with that study of absorption of UV radiation at the range of 200 to 400 nanometer is the colorless compound. In case 400 nanometer is the colored compound is a visible region. So the colorless compound absorbed UV radiations and in both UV spectroscopy and UV visible spectroscopy. In the valence of electron absorbed energy, thereby molecule undergo transition from one state to another state, mean ground state to excited state. The absorption characteristic depends upon the electron present in the valence of cell of the compound. And electronic transition is a four types of electronic transition present in the UV spectroscopy. One is sigma to sigma star, pi to phi star, sigmas to non-bonding, pi to non-bonding. So that is the transition of the UV spectroscopy. First one is sigma to sigma transition, pi to phi transition, and n to sigma transition, n to phi transition. These are the electronic transition present in the UV spectroscopy. Okay, this transition, which bonding of sigma electron is excited to antibonding sigma orbital. That is called sigma to sigma star. So similar, it is the sigma to sigma star. So n to phi star and n to phi star and phi to phi star electronic transition. So what are the laws involved in the UV spectroscopy? Is the Bees-Lambert's law. So these combined laws that amount of concentration is observed so proportional to concentration of the absorbing substance and also thickness of the absorbing material. Okay, that is the equation of A is equal to lambda BC or gamma BC. The A is equal to absorbance and gamma is the molar absorptivity with the units. Then B is equal to path of sample and concentration of compound. So what then instrumentation? So what are the apparatus are involved in the instrumentations or source in instrumentation? So first one is light source and filter and monochromatic second one, and there was sample cell and four detectors and recording units. So what are the light source involved in the UV spectroscopy? First one is so it should be stable. It should be provide lights sufficient intensity. Then it should be economical and it should be emit continuous spectrum. So it should simple construction of abstraction. Okay. First one is hydrogen research lab. Second one is deuterium lamp. Second is xenon arc lamp. And fourth one is tungsten halogen lamp. So what are the hydrogen research lamp means? The hydrogen research lamp are pair of circuits in an enclosed glass tube filled with the hydrogen gas. When current is passed through the electrodes, is maintained high voltage. So discharge of electrons occurs, which hydrogen molecule is a true cause emission of UV radiation. It is the deuterium lamp. It's one source of light source. It is similar to hydrogen research lamp, but instead of hydrogen gas, deuterium gas used. So it provides radiation range to 185 nanometer to 80 nanometer. So spectroscopic technique is not useful below 200 nanometer. Okay. Then it is similar to xenon arc lamp. It also only using the light source. This also one are using the light source. Then one is monochromators. So monochromators device used to polychromatic light converted into monochromatic light. Okay, two types of monochromator. One is a prism. Using prism monochromator is called as prism monochromator, and grating monochromators made up of glass or quartz alkyl halides like potassium bromide, sodium bromide. That's it. So two type of this grating. There is a diffraction grating, transmission grating. Okay, then on this is the equation of grating transmission or grating monochromators. This one affecting monochromators and the filters. What are the filters used in the UV spectroscopy? This filter is device which allow only light wavelength to pass through the absorbed unwanted radiation. So it is two types of filters. One is absorption filters and is interference filter. So sample cells is used to hold the sample in a UV spectroscopy. It's made up of glass, then special optical glass and quartz in infrared and UV. So finally, detectors. First one, sampler placed in a first one light source. Second one is some monochromators and filters, and finally sample cells. And finally go to the detectors. So the detectors use what are they using? The detector means in the this light's energy is converted to electrical signals. That's what they displaced in the detector. So the samples absorbing the electromagnetic radiation. This radiations go to the light source, and light source is converted to monochromatic light, and monochromatic converted into filters into sample cell in present and finally detectors. So this detectors type of detectors. First one photomultiplier, photovoltaic and phototubes. So the photomultiplier tubes, it works on the principle of multiplication of photoelectrons by secondary emission of electrons. These are the detectors in a UV spectroscopy. So one type of detector. So the incident photons here, these are the detectors, and rhino is current. This is the voltage. Then photovoltaic side, when the light falls into the selenium layer, the electrons are generated taken by the photocap. This place photocap, and the electrons get accumulated, which result in a generation of electric current. So this current flow causes deflection in the galvanometer, which gives of the intensity of the radiation. This is also one type of detector. This is phototube. When the lights fall from this cathode, the electrons are produced that travel to the collector and anode and generate current. The amount of current generated is directly proportional to the intensity of light. Means how many amount of intensity of light is produced is directly producing the amount of current also generates. Here the DC amplifiers are recorded or reader. So what are the type of UV spectroscopy means? First one is single beam or double beams. So these are the single beam UV spectrometer. These are double beam UV spectrometer. So what are the applications involved in the UV spectrometer? First one is identify the detection of impurities. So UV absorption spectroscopy is one of the best method for determination of impurities in inorganic, organic molecules. What are the organic molecules? Means carbon containing compound. For example, acetic acid, methanol, ethanol, whatever it is, it's carbon containing compound. So identifying the impurities of the organic solvent or organic molecules, whatever it is. Second one is structural elucidation of organic compound. The structural elucidation means useful for spectroscopy. The structural elucidation of organic molecules, the presence or absence of unsaturation of the presence of heteroatom. And third use is quantitative analysis. What does quantitative analysis mean? UV absorption spectroscopy can be used for the quantitative determination of the compound that absorb the UV radiation. What are the compound that absorb the UV radiation? That is a quantitative analysis. And qualitative analysis mean which are the spectroscopy then characterize those type of compound which contain the amount of and qualitative. This type of radiations are present here. This also using. Then detecting impurities. So UV absorption spectroscopy is one of the best method for reduction of impurities in organic molecules, means carbon containing molecules. So it's been how I identifying addition of peaks can be observed in a UV spectroscopy. For example, we are identifying the benzene's lambda max, that also identifying to the another absorption or occur, means it is benzene appeared as common impurity in a cyclohexane. Its presence can be easily detected by the absorption of 255 nanometer. So what are the solvents we are using in the UV spectroscopy? One is two types. One is polar and non-polar. So doing spectrum at particular wavelength and one particular condition. But chill, particularly in saturated wavelength, is another condition. So what are the nature of the solvent using changes in a spectrum due to nature of the solvent and nature of the absorption band and nature of the solute. So nature of the solvent is the most commonly used solvent 95% ethanol because it is a cheap and good dissolving power, does not absorb radiation in 210 nanometer. And in the choosing solvent, and consideration must given not only its transparency, but also its possible effect on absorbing system. And benzene chloroform carbon tetrachloride can't be used by because they absorb range of 240 to 280 nanometer and should not itself absorb radiation in the region under the investigation. What are the common solvent in a UV spectra? And solvent name is water, methanol, ethanol, ether, cyclogen, dichloroethane. This nanometer 205, 210, 210, 210, 220. So effect of solvent. The solvent exerts profound of influence of quality of shape of the spectrum. For example, acetone in a extent 270 nanometer, we are identifying 2 is adding to acetone in a water C64, 264 nanometer. So different spectroscopy and the solvent and accuracy spectrophotometric analysis of sample content, observing interference may be marked by improved technique of different spectrophotometric. So what is the advantage of the different spectroscopy or spectroscopy? The selectivity and accuracy of the spectrophotometric analysis sample containing observing the difference may be markedly improved the technique different spectroscopy. So derivative spectroscopy means another simplest method for increasing the selectivity is the derivation of spectra. This operation allows to remove the spectral inference and consequently to increase the selectivity as well. So it involves the conversion of normal spectrum to first and second higher derivative spectrum. Okay, so multi-component analysis. The derivative spectroscopy is shortly DS, has been mainly used to pharmaceutical analysis to assign main ingredient in a presence of other component of other degradation product. So correlation of some physiochemical constant, or example, reactions and complexation and binding constant. So this main disadvantage of derivative spectroscopy is the poor reproducibility. Thank you for patient. First one is finally short discussing about UV spectroscopy. So atoms are molecule normally present in the ground state. We are applying UV force or electromagnetic radiation. Ground state is going to exodus state. So is carrying this certain energy. We are applying the stored UV energy suddenly is going to the exodus state to ground state. So these atoms are molecule. How much energy is carried to the exodus state to ground state, it is called lambda max. I mean wavelength. So maximum the maximum wavelength is called to lambda max. Okay, these are the lambda max. Okay, thank you for patience.